Hope everybody's doing well today. Today we're going to talk about similar polygons. This video coincides with lesson 9.3 in your textbooks. Okay, so in mathematics, when we talk about similar, we're talking same shape, different size. Okay, in order for two polygons to be similar, though, a little bit more involved. Okay, so their corresponding angles have to be congruent, and then their corresponding sides have to be in proportion. So what does all that mean? Okay, so here we've got two triangles. You got your big one and the little baby one. Okay, so let's talk about corresponding angles. All right, so angle A corresponds with angle X. Okay, and they're congruent, meaning they have the same measure. Okay, angle A measures the same number of degrees as angle X. Okay, and then angle B corresponds with angle Y, and then obviously Z goes with C. All right, angle C, angle Z are going to measure the same number of degrees. Angle B, angle Y going to measure the same number of degrees. Okay, corresponding sides. Okay, so side AB goes with XY, ZY goes with CB, and then AC obviously goes with XZ. Okay, and they're in proportion. So, for example, if we're told the ratio of the corresponding sides is 2 to 1, all right, so let's say we get something like this, 2 to 1, okay? So, for example, if CB is 2, that means that ZY is going to be 1. If AC is 3, that means that XZ is going to be 1.5. And then if AB is 4, XY would be 2, all right, because of that 2 to 1 ratio, all right? And then we could say that triangle ABC is similar to triangle XYZ, all right? And that's your similar symbol, okay? So this concept is going to be presented two ways, all right? So the first way they're going to present it is they're going to say, that the polygons are similar. You got to find the missing side, or in this case, find the value of X in each pair of similar polygons, okay? So, you need to see here that, 10 is going to go with the X, okay? So, again, we're solving for X. So that needs to be half of our proportion, right? 10 and X, okay? So the 10 came from the small triangle. The X came from the big triangle. Now, what we use over here is up to you. You can either use 6 and 9, or you can use 8 and 12, right? 6 and 9 go together, and then obviously 8 and 12 go together. You couldn't use 8 and 9 because they're not corresponding sides, okay? So let's say we decide to use 6 and 9. The 6 is going to go on top, the 9 is going to go on the bottom, again, because we got small on top and big on the bottom, okay? We can simplify these, right? Divide these both by 3, and that'll give us 2/3. And then I can get from 2 to 10 by multiplying by 5. And then 3 times 5 is going to be 15, so X is going to be 15, right? And then we could have done the cross products and solve that, solve that way as well, all right? And it would, same thing would hold true if we didn't use 6 and 9 and used 8 and 12, okay? So again, we got 10 over X, okay? And now we're going to use 8 and 12. The 8's going to go on top because that's the small, and the 12 is going to go on the bottom. So again, if we simplified, right, this time we divide them both by 4, right, we'll get back to that 2/3, okay? And again, you're going to get X is 15. Let's take a look at this one. Don't be fooled here, guys. Don't be fooled, all right? So, you might think that the X goes with the 2, but it doesn't, all right? The X actually goes with the 5, all right? Because the X is the long side of this rectangle. The 5 is the long side of this rectangle. Basically what they did here, guys, is they took this rectangle and they rotated it. So don't fall for that trap, okay? So here again we've got, the 2 goes with the 4, okay? and then the 5 goes with the x, right? And then obviously to get from 2 to 4, we're going to multiply by 2. And then, 5 times 2 is 10, right? So x is equal to 10. Okay? We can see, 2 is half of 4, 5 is half of x, or 5 is half of 10. Okay? And then obviously you can do your cross products as well. Okay? All right, let's talk about the other way that this concept will be presented. Okay? So here, they're going to give you the polygons, right? And they're going to give you all your numbers, and they're going to ask whether or not the polygons are similar. So your answers are either going to be yes or no, and then you have to explain why or why not. They're going to ask you to justify your answer, all right? So hopefully here we can see that the 2 corresponds with the 6, and then the 3 corresponds with the 9. Well, obviously, to get from 2 to 6, we're going to multiply by 3. And then 3 times 3 is 9. So these polygons are similar, okay? And then, so our answer is yes. And then our justification could be something like this, where we go 2 over 6 equals 3 over 9. Okay, so we can simplify both of these to a third, or we can show that the cross products are equivalent. 2 times 9 is 18, and 3 times 6 is 18. So again, yes, these rectangles are similar. Let's take a look at these, all right? So you got your 4 going with your 2, and your 10 going with your 6, right? Well, to get from 4 to 2, we're going to divide by 2. If I take 10 and divide that by 2, that's going to give me 5, not 6. So now we know that these guys are not similar. So, this one is no. All right, and then your justification would be something like this, where we go, 4 over 2 does not equal 10 over 6. Okay, for this one, we went big to small, and then the same thing over here, where big is on top, small is on the bottom, right? 4 goes with the 2, 10 goes with the 6, or 10 corresponds with the 6. All right, so I hope that this helped, and talk to you guys soon. Bye-bye.